Alright, good evening everybody. Today we're doing something a little bit different. We are in MATLAB, and I'm going to be showing you how to do a simulation in MATLAB and then bring it into Blender. So first of all, we have to get a simulation going. So we're going to be doing something not too difficult. We're just doing a projectile motion simulation. So in order to do that, you're going to need an initial velocity. They're going to say that's 20. And that is going to be in meters per second. Now when you have a projectile, you're going to have a few forces on it. You're going to have drag, and you're going to have gravity. Gravity is super simple to simulate. That is just AY, acceleration in the y direction, is equal to negative 9.81 meters per second squared. Also, you don't have to use MATLAB. I'm just comfortable with MATLAB. That's what I've been taught, so that's what I'm using. You can really do this in any programming language that you know. Java, Python, C++, whatever you want. Yeah, like I said, I'm just using MATLAB because that's what I'm familiar with. So, drag is going to be resisting the force, no, not the force, the motion in both x and y direction. So that's a little bit more complicated, so we're just going to neglect it for this time. Maybe I'll do another one where we include it. But we're just going to say that's 0. And that's meters per second squared. You need a launch angle. We can call this the or theta. You can call it whatever you want. I'm doing this in degrees because that's easier. At least that's what I think. And then you're gonna need some positions, some like x and y positions. So this is going to be in meters. And then we're going to need basically an FPS or a frequency, if you will. So this is how many times per second you want your simulation to run at. So you can call this hertz or FPS. That's however fast you want it. And then you want your time step to be equal to 1 over your frequency. So this is going to be just 1 over seconds. So in this case it's going to be 1 over 60. So a single frame is going to take 1/60th of a second, basically. And then you can set your total length of your simulation time. So in this case, it's going to be 4 seconds. But you can make that however long you want. And any of these you can change. You can make it what you want. If you want to simulate, say, what it would do on the moon, for example, you could change the AY to be the gravity of the moon, which is 1.62 meters per second. But we're not going to be doing that. You can do it if you want. Feel free. Okay. So now we can start getting into our simulation. And then we can just call this setting up simulation. Okay, so this big T is going to be your time that you're saving. And so we need a velocity for x, and that's going to start off as vi times your cosine degrees of your angle, in this case theta, and then the same thing for vy, and that's going to be your velocity in the y direction, and that's just vi times sine d theta. If you had your theta in radians, you would just leave off the d. So, like that. So that would give you the sine of theta in radians, but we're using degrees, so we'll leave the d. And for our actual loop, we're just going to type 4, not fought 4, is 1 to your frequency times your time minus 1. And then we're going to be setting our x velocity and our x position. So it's vx I plus 1 equals vx I plus ax times dt. So this is your acceleration here, this ax, so that's in meters per second squared, times your change in time, so your time step. So it's going to be meters per second times a second, so that's going to convert to meters per second, and so you can just add those two together. And we're going to do the same thing. The reason we're starting at 1 and then I plus 1 is because we already set our first Vx and our first Vy. So to do our our x position, we do the same thing as xi plus 1 equals xi plus, but instead of acceleration, it's going to be this value, vxi times dt. So this is meters per second times a second, times a second. That'll give you meters, and you can just add that together. Now we're going to do the same thing for our y. I plus 1 is vyi plus ay times dt. And since this is a negative number, we're going to actually be subtracting this. But we already have that up here, so we'll just leave it as a plus. And we'll just copy, paste, and then change what we need to change. So that's y, vy. And then we can just update our time, so that's capital T, I plus 1 equals T, I plus dt. And then if you plot your x and y, and then you can see you have this arc basically that we generated. That shows your parabolic trajectory. Now if you want to, you can change this, say 80 degrees, and you can see it's higher. And if you change it to something like 20, you can see that it's much shorter, and it goes lower, basically. And then if you want to, you can change your initial velocity, say 40, and then it starts to go up, and then you run out of your time, because that's only 4 seconds, we're only simulating 4 seconds of it, it cuts off when it reaches 35 meters. So it goes up, hits about 40, comes back down, hits 35, and the simulation just ends because it's not long enough. But feel free to adjust this to however you like. But we're going to change that back to 20 and whatever. Okay, so we have this. And now for the most important thing, we're actually going to write our data to a text file so we can bring it into Blender and read it. So we're just going to say data is equal to x prime. So what this prime here does is right now these arrays or vectors are basically like this. They're horizontal, so what it's going to do is it's going to flip that and make it vertical. So that's just going to make it a little bit easier to bring into Python or another programming language, but Blender uses Python, and read it and use it for positioning for our objects. So it's x prime, y prime, and then time prime. You don't actually need this time prime, but I feel like it's just useful just to make sure everything is correct. When you're bringing into your programming in Blender. And then we're just going to use a write matrix data, and then this is going to be your file name. So we're just going to call this projectile animation, and then you want to use the delimiter, and then you're going to select that as a comma. Oh, and then for this you actually need a file extension, so the easiest thing to use is going to be a .csv. So if you run that, just write this, just make a name, cool, it'll generate your plot for you, and then you just find it real quick. This is going to be in wherever your file is located. So, as you can see, here is all of our data. That looks absolutely fine. Cool. So we're going to open up a new Blender. Wait for that to load. New project, delete the default cube, bring in a sphere, or whatever you want, really, it doesn't really matter. Make that whatever size you want. Maybe do a subdivide, just to make it look a little bit prettier. And then we're going to go into your scripting. Let's see. Okay, yes, scripting. So, new. So we're going to need a few imports. So we need your CSV, and then you're going to need to import view.py, which is your Blender Python library. So you need to locate your file. The easiest thing to do is just to bring it down into your PC. So if you're at your PC, you go to your local disk, and then you just drop it here. This is a previous run. It's the same data, so it's essentially the same. I'm just using it for convenience. That's going to be your file that you just created. So you need your path. So that's going to be C. If you have it in the same directory as I do, it's going to be C:\/ test data.csv. Oh, and the double backslash is if you are using Windows. It's going to be slightly different if you're in Linux or Mac. So just be aware. So then you're going to type with open your CSV file as file name, and that can be whatever you want. And then data is list csv.reader file name. So basically what this is doing is it's bringing the data from your file into your Python environment as an array, essentially, from my understanding. I'm not a Python expert. What I learned is MATLAB, but in order to use Blender, you have to use Python. Okay, so this next section of the code is going to set keyframes for your object in order to animate it. So you're going to go I is equal to 0, and then for D in data, that D can be whatever you want. Positions is equal to your data at position I. So right now you have a bunch of things like this, 1, 1, 1, whatever. So basically, this position is going to be set to this number in your data array. So this is a 2 length array. So this is position 0 and this is position 1, because programming languages are off by 1 for arrays. That's just how it's programmed. So basically we're just going through every entry in the data array, and we're setting a position to that number, to that set of numbers, essentially. And then you can't forget your I plus equals 1, or you could do I equals I plus 1. It's just a little bit faster to type plus equals 1. Cool. So you need your object is equal to bpy.data.objects, and then this is going to be whatever your object is named in this collection here, this viewer. So mine is sphere, so it's going to be sphere here. And then you need to set your frame number to 0 or 1, whatever you want, doesn't really matter. And then you're going to do for position in data. So that's going through everything in your data array. Actually, you know what? I don't think you need this. You could leave it off if you want. I can try that in a second, but let's just finish this. So you're going to want bpy.context.scene.frame set, and that's just going to be your frame number variable. And then you want to set your object location to float position 0. So that should be float. So what this is doing is your position is a 3 number array. This one being your x position, this one being your y position, and then the last one being your time position. So basically this float position 0 is getting this position and returning it as a number that the Python for Blender can read. And one thing to note, this red here is your x-axis. This y here is your y-axis. And then there's another axis here, your z. So in Blender, or no, not Blender, in MATLAB, we said your x-axis, and that's the same, but we said y is the vertical. But in Blender, z is the vertical. And for this ob.location, you need 3 numbers for x, y, and z. So to make most sense, what you can do is 0, and that'll just set your y position to 0 for every single frame. And then you can do float position 1. And that will grab your second number in this array, also known as your y or z position for Blender. Okay, and now for the most important thing, ob.keyFrame insert data path equals location index equals -1. I'm not 100% sure what that does. The index, but it should be setting the keyframe to the location that you just set up here. So you could set this to rotation, you could set that to essentially whatever you want. You just have to look it up to make sure that you can actually set it, but that should be absolutely fine. So for example, another one I'm going to be doing is where you have a position and also a rotation, and I will be showing that to you maybe in another episode. And I lied, this is the most important one. Frame num plus equals 1. Cool. So you can run this. Oh wait, maybe I forgot a comma. Hang on. Goes float position. Oh, yeah, I just forgot a parenthesis. You just want to make sure that each pair has each parenthesis has a matching pair. So that shouldn't actually be there. This should be at the end because that's for the end. Because that's making an array for the location. Okay, so we can run that. And I'm a setup. That should be CSV, not VSC. Cool. So run that. Programming, am I right? Hang on. I'm not quite sure why that's not running. Oh, wait, no. I must say. Yeah, when you're programming, just make sure to check your spellings and whatever. There you go. Okay, cool. So if you go back to layout and you select your sphere, you can see all these keyframes here, and that is your position that you set in Blender. So we can just watch this real quick. And then, since I never actually updated Blender, it's thinking it's 24 frames per second, but we said in our program we would like it to be 60 frames per second. You have to change that. So now it'll play back at the correct speed. Nice. And then you can doll it up however you want. You can add a HDRI, you can add whatever you want. And so it should look like this. And that's all I have for you today. If you liked it, make sure to hit that like button. If you loved it, make sure to subscribe. Thank you very much for watching, and I will see you next time.